Okay, everyone. Yeah, Jonas invited me if I could give a quick talk at his newly founded meetup. So I went ahead with my favorite topic, Kubernetes security from A to Z. Just in the beginning, quick introduction of myself. My name is Tjark, Rasche. I work for Mercedes-Benz, but a very important step, especially for the camera, I'm not here as a representee. So this talk is not a representation of any corporate policy of Mercedes-Benz. I am here as a private person. I've been working with Kubernetes for at least 6 years. I've been actually working with Kubernetes for longer, but that's like my professional career with it. The last 2.5 years I've spent at Mercedes-Benz, where I'm in the team that builds the main Kubernetes platform. We run somewhere around 900 to 1,000 Kubernetes clusters across several data centers in the world for all of Mercedes-Benz. And I work there as a cloud software engineer, which is my official title. I'm pretty specialized on Kubernetes part itself and not much of the cloud infrastructure and networking part, and especially on Kubernetes security and on Kubernetes, like extending Kubernetes. So I do a lot of work in writing operators, building custom extensions, stuff like that. Just a quick overview, like goals of the talk. It's pretty much just an introduction, and basically like a list of things to Google, which sounds a bit stupid, but Kubernetes is nowadays so complex and such a wide area of expertise that every single topic in my agenda could easily be its own talk. In fact, if you talk to people in SIG security, like the people who do Kubernetes security as their main job, it's way more than a talk. You could do a whole conference for every single of the subtopics. But I'll go over everyone briefly, and I'll mention, like, in my mind, every topic that is important to know about if you want to go through Kubernetes security. And if you guys want, we could go more in depth to a couple of them. And also, as a preamble, I'm not an expert on all of these topics because no one is an expert on all of these topics, right? You'll see probably where I dive deeper, which topics are my main ones. You can probably also, if you're very familiar with the CNCF landscape, see the stickers on my laptop and my artifact signing jokes, which is what part of security is my specialty. But yeah, so let's jump into it. And here you can see again the agenda, but it doesn't make really any sense to go over it as we're going to talk over it. So first of all, how can we think about Kubernetes security all in all? I just want to make a few concepts and things clear and give a quick overview. So how does a Kubernetes cluster actually work? It's a bit of a prerequisite to know at least like the basics of Kubernetes architecture for this talk. So I'm just going to go over it very briefly. The important thing is a Kubernetes cluster basically is nothing but a REST API and controllers watching the resources that are being added or edited in this REST API, right? And so that's also where you can draw a few lines, some sort of boundaries, which we can think about that are important to secure in our cluster. And you can give them an order of importance, what you should think about first, and then go ahead. So, and obviously the first and most important one is quite opposite the kube API server. So everything you do, every single kubectl edit, every single kubectl get, every request, everything you actually do in a cluster will always go through the Kubernetes API server. So if you manage as an attacker, and that's always the way to think, what can I do as an attacker to compromise the Kubernetes API server, you are able to compromise the whole Kubernetes cluster, always. Because that's the boss, and it's where every single authorization and security step will happen. And the same is true for the etcd database, which is in 99% of the cases the database behind Kubernetes. If you're running very fancy managed Kubernetes from Google, or if you're running like K3s or stuff, that database may not be etcd, but a different one. That doesn't matter. The important thing is if you manage to compromise the persistence layer of your cluster. Obviously, the same is true because you then indirectly have compromised the API server. And so that's one large boundary, and you could basically, if you draw the boundary around that, it's the boundary around the whole cluster. That's very important to understand. So obviously the first things you should do is make sure your API server is secure, right? And the second very important boundary, the only one we're also going to talk today, is basically the node. Like there's a lot of attack vectors. Most applications will run on nodes, and most people run on managed Kubernetes, so they don't even think that much about etcd and API servers and controllers and stuff. And so if you run applications, those applications will have security weaknesses. All of them have. And oftentimes, for example, if you can escape running pod, like if you have if you manage to execute code in an application that runs on Kubernetes, and then you manage to escape the pod, you've breached the boundary of a node, right? But then you're not yet, most of the cases, in control of the whole cluster. You're only in control of the node. So there's lots of stuff you can do there, but not everything. And that's a very valuable thing to think about, because maybe you should look after being sure that if someone is able to control a node, he's not able to take over the whole cluster, which actually isn't that easy, but that's already a very deep topic. So let's go a bit more into the details, and I'm actually going to, like, in a very, very basic order. It's not guaranteed to be perfect, but from most critical to, you can think about it when you've done all the other things. So the first and easiest step to think about is actually authentication and authorization in Kubernetes clusters. Authentication is the same as in every application. It's just the question, who are you? And very important to understand is that Kubernetes actually has no concept of users itself. It expects stuff like that to be managed externally. This is not the case if you're using something like Red Hat OpenShift, which actually has user management, but if you're just running vanilla Kubernetes. And so you have to manage users externally. You can do that by distributing certificates, for example, from your own CA. Or you can do that, which is obviously the preferred way, via an ODC provider. So, for example, if your company already has an Azure Entra ID tenant, which a lot of companies have, or Google Workspace or something, you can actually directly use that user management. And there is the concept of service accounts for workloads inside the cluster. There's a token that they get mounted that automatically can get mounted in pods, and that's the concept of Kubernetes has for authenticating workloads inside the cluster itself. In general, you should not use service accounts for different things, for anything besides actually authenticating workloads in your cluster against the cluster API. It is possible. You can just create your own kubeconfig with a token of service account, but that's going to be it's a big no-no, especially for like auditability reasons, because then everything just looks like your service account did. And so the second very basic concept, and probably also well known by most people who use Kubernetes on a daily basis, is authorization, which is always the question is, what are you actually allowed to do? There's also a couple of ways to do this in Kubernetes, but the only one with any real relevance nowadays is RBAC, which is role-based access control. I think, which is probably also known by most people here who use Kubernetes. You can basically just define roles and cluster roles. So roles is the namespace version, cluster roles is the global one, and choose what verbs and what stuff they're to do. So you can always allow, that role is allowed to do this thing on the following 3 Kubernetes resources. And you can use role bindings to assign those. Probably also very well known. So what are the general best practices for this very first step, which is basically a basic securing your API server? It's the same as in every access system and every access control system. You should always go by the principle of least privilege. So if you're thinking about what access for example, does my application running on my cluster actually need, you should probably just give it none. Because most applications never have to talk to the Kubernetes API server, right? And most applications will have some sort of security vulnerability, like a remote code execution somewhere, especially if you're running like older Java stuff and such. And so it's best to start at actually giving them no permissions at all. It will be enough for a lot of applications. And then move forward from there. If they need something, think about why they need it and grant them. And a step that I've never seen in practice, I introduced it at Mercedes, is actually review your RBAC policies regularly. Because oftentimes when debugging, especially when you're debugging in real clusters, you tend to add stuff and you don't question, like very seldom people question why they gave this permission a while back. And pretty cool tools to use for that, which are both pretty unknown and actually quite unmaintained, but both still work. At least they did a week ago when I last used them. There's a tool called Rasche, I don't know, and who can, both are pretty good for watching actually. Who can is basically you can see who can do X, and then you can see a list of all service accounts that are allowed to do that. And request is the same thing, just the other way around. Very, very helpful if you're thinking about actually implementing something like reviewing your RBAC policies, because no one is going to go over a repo and watch every single policy they have, right? And so, yeah, that's the very basic step of making sure your API server access is secured with Kubernetes' own onboard tools. If you're using managed Kubernetes offerings from one of the well-known cloud providers, there is almost certainly a solution to do this more elegantly through their fancy tools. Like Azure has an IAM mapping directly in it, in EKS you can do the same with their IAM solution stuff like that. So the next step in my little cascade would be pod and container security itself. And so as a first step, very important to know, because especially when talking, I don't know, I work in a team which runs Kubernetes for development teams, and obviously development teams are supposed to know their software and their domain. They're not supposed to be experts in infrastructures, and I've heard the sentence a lot that, oh yeah, I understand containers, they're basically just a VM, right? It's a VM that starts quickly. Well, they're not, and it's actually quite important to know that, especially if you're thinking about security. And looking into Linux, there's actually very little isolation, real isolation between containers. And in a default setting, if you just deploy, if you get a new Kubernetes cluster, even if you get it at fancy managed Kubernetes offerings, and just deploy a container and do anything, it's very, very easy to do privilege escalation. It's a single command to escape your container and be on the node. That's something a lot of people actually are not aware of, because cloud providers don't really tell you that, because they don't care, right? If you're buying managed Kubernetes from some offering, you're buying the VMs underneath them. So the security boundary, the big hyperscalers are thinking also on boundaries, for them is not your cluster and not your container. What we talked about, the node, theirs is the VM. So yeah, that's stuff we really have to think about. So escaping containers is very easy. Actually, there's just a huge vulnerability in Run C, the component that actually runs containers, 3 days ago. Probably a couple of people noticed. Yeah, had a very sleepless weekend. So yeah, and now we're basically talking like the boundaries introduced. This is the main entry point for actually securing your node itself, right? The basic stuff for the API server was the most important thing to secure the boundary we drew around the API server. And so now we're doing the basic things to ensure that actually are one step down the ladder, that our node boundaries actually count. Yeah, so what are the standard tools within Kubernetes to ensure at least some level of protection? There used to be a very complicated thing called pod security policies, which got removed in v125. Yes. Replaced by a way better solution, which is way simpler to use, and simpler to use is always better. And Kubernetes, there's a thing called pod security standards. And pod security standards is basically nothing else than you can apply 3 rules of security standards to your container, either privileged, baseline, or restricted. And basically, those, if you apply those, the upstream Kubernetes project, the maintainers tell you, we decide what security measures fit into these categories for you, so you don't have to think about low-level fundamentals. For example, you could do restricted, which is the recommended thing for you, but it will block several things very few people want to think about. It starts with basic stuff that most people probably, or a lot of people already think about, like you're not allowed to mount host path volumes, so not allowed to mount volumes from your node that it's running on. You're not allowed to run as root, so you can't just run as user. There's a flag you can set on a container, and that's not allowed. Or you cannot, there's a very funny flag called allow privilege escalation, which defaults to true in Kubernetes. And that's, for example, not allowed as well and restricted. And so the idea is those are just the basic settings. There's a lot of stuff you can set on low-level Linux settings on process and OS level, which they just decide for every little thing which category they fit into, and you can apply one of those. So ideally, you should run everything in restricted, every application at least. It won't work because, for example, older Java JDKs need extended access to some OS level memory management and stuff like that. So that's why baseline is there. Baseline is the idea every application will run on this. It's basically just don't run as root and don't mount the host file system. A privilege should actually never be used. It should only be used if you're actually running components of the cluster itself. So obviously, if you want to install your own CNI, it has to be privileged because it is OS level IP table stuff or fancy BPF stuff. Or if you run a lot of monitoring tools, need privileged access, Datadog, for example, or Elastic, stuff like that, because they do stuff like scan processes on the host machine. But in general, if you're running an application which is served to any kind of end user, you should never have to run it. It's privileged. Privileges, containers will be allowed to do everything. It's basically just the privileged container can control the whole node. There are also way more advanced options within which are supported in quite elegant way actually by Kubernetes. Seccom and FARM are the main thing, but those are actually basically Linux features which you can configure through Kubernetes. We can dive deeper into that, but I thought they're probably quite out of scope for a quick overview. And also, those are pretty advanced, and like, as the idea of the talk is to go through step by step what is the most important things. You should probably, once you have your pod security standards in order, move further on in the list, and then if you got everything settled, you can go back to the armor. Yeah, so the next step in securing actually our cluster. So now we have ensured that not everyone can talk to our API server and do stuff and create stuff there, and we have ensured that applications can't do anything, ideally, in our cluster. And we have ensured that, ideally, applications can be run in a way that allows them to escape their containers. But what we have not talked about at all yet is network security. And per default, as always, the general topic is Kubernetes is very insecure by default. All containers can actually communicate with each other, which is not that big of a problem for Kubernetes itself, because, as mentioned, there's mechanisms for the API server and everything else is basically unauthenticated anyway. But this can be a very big problem for domain-level security, right? If you have applications that have databases, it's very common to have very weak credentials when running databases in Kubernetes because everything is shared by secrets anyway, and you assume it's a protected network. But for example, if you're trying to run multi-tenant clusters where multiple teams run applications on a single cluster, which is a very common thing, you have to remind that a pod in one namespace can easily talk to a pod in another namespace. So probably in a lot of clusters, I've seen it myself a lot of times, the production database from the one team can easily be accessed by the database in the other team, which is a problem, especially if you're in Europe, like not in Switzerland. I don't know if GDPR is applicable in Switzerland, but yeah. So, but actually, there's a very, very easy tool to handle all of this, which is called network policies, which are also quite well known. They're very basic. They allow you to very fine-grained control traffic flow from and to pods. It's basically, you can just say, similar to label selectors from deployments and stuff, you can say every pod that matches this label is allowed to talk to this pod that matches this label. So you can go from every single ingress traffic should be allowed to only these two pods can talk to each other. And obviously, again, the principle of least privilege applies. So in an ideal world, you would start with deny all network policies, which is a thing some CNIs, so some network interfaces providers in Kubernetes support. For example, in my day job, we use Calico in our self-managed Kubernetes clusters, where there's actually a thing, there is actually cluster-wide network policies. So we actually deploy a real deny all. So if customers or development teams create new namespaces, they will still have deny all. That's sadly enough not very common. Cilium has a similar thing. They have their own complete set of CRDs for doing stuff like this, but the other CNIs don't, at least to my knowledge. So in there you have to have either automation to deploy net polls to new namespaces, or you have to just disallow creating new namespaces, stuff like that. And some additional things to think about when thinking about networks security is, in general, your DNS in Kubernetes should be thought of as critical infrastructure. I mean, everybody knows the joke. I used to have a sticker on my laptop. I don't have it anymore. It's always the DNS, right? But everything goes through services in Kubernetes, which are basically just a cooler name for DNS records. And so if someone is able to hijack your core DNS, the typical component within Kubernetes clusters running, they can redirect traffic however they want. If you've got your net polls, etc. in place and perfectly configured, this is not an issue because net polls work on a CNI level, so on a lower stack in the network layer, on a lower OSI layer. But if we're honest, our beloved principle of least privilege in practice is never fully applied, right? Because we always forget to review our policies. So just think about core DNS should be as critical as an infrastructure in your Kubernetes cluster, basically as your API server itself, probably. Or nowadays, it's oftentimes not core DNS anymore. I think the managed Kubernetes offerings run with their own DNS, but I'm not sure. Yeah, and obviously another very nice to have would be mutual TLS, so that pods in general communicate with each other, which is something Kubernetes just has no opinion about. Some CNIs provided, and obviously service meshes. There's a typo there. So if you're running Istio or Linkerd or something like that anyway, for your observability needs, that'll do that for you. And the fancy new CNIs are also the eBPF stuff, Cilium, and I think Calico with eBPF Walk also supports it to actually encrypt your traffic for you. But again, that's a bit more advanced. You should probably go further down the list before you care about mutual TLS. So next important step, and the next thing where Kubernetes by default is very insecure, is secrets management. Kubernetes secrets are just strings stored as base 64 encoded, persisted to the database, which is wild, right? If you told that to anyone who has written applications for end users the last 50 or 60 years, they would say you're insane. So you should at least make sure that you're, like, in a very basic step, make sure that your persistence is encrypted. So your etcd disks at rest, which is very little help anyway, because again, access to the API server also means access to every single secret in your Kubernetes cluster. Again, like the first bound we talked about, which can be a huge deal. So, and again, the defaults are there's just no access control. So make sure all those RBAC rules we talked about also apply to your secrets and stuff. And Kubernetes itself, it's basically, you can't call it secrets management, it's just storing strings, right? The difference between a config map and a secret is just the basic 64 code. And there's a bit of fanciness because there's special kinds of secrets, like you can do container immutable secrets, and those are a bit more advanced nowadays, but it doesn't matter. Like, there's no rotation or expiry mechanism and no read auditability. You can have the audit logs on your Kubernetes API server, but they're very basic, so you can track someone. If someone actually changed your secrets, stuff like that, you cannot track, for example, the access to them. So very basic, you should actually just not use Kubernetes secrets, at least not to store your actual secrets. So what should you do? I already mentioned that. At the very least, make sure that you have encryption at rest enabled for your etcd, but this is a very low bar, right? Because encryption at rest doesn't do anything. Most of the clusters run 24/7, and so it will be unencrypted, at least in memory somewhere. But you should use at least that. And if you're using managed Kubernetes, try to bring your own key if possible, because otherwise it's not really encrypted. It's just someone told you it's encrypted with their key, and you don't know how they manage them. Shout out to Microsoft for their great key management. Read the news the last couple months. Yeah, and ideally, you should definitely use some sort of external secret manager. I'm very familiar with HashiCorp Vault, or now OpenBow, yeah, it's called. But the other ones work fine as well, Azure Key Vault, etc. Again, bring your own keys and do the RBAC restrictions for secrets. And ideally, a very common pattern that uses external secrets manager, which was in the press very famously for not having any maintainers. They do now. So that works very well. They think this, you can do stuff like secrets rotation. It adds a lot of the features that miss here, especially expiry mechanism and rotation, and syncs them. Do what external secrets can do, for example, is get a new secret every 24 hours from your vault and replace that one in your storage. But it doesn't really change that your current secrets, which are accessible, are still stored unencrypted in your etcd. So in an ideal world, you would use the mechanisms that your secrets manager provides for injecting secrets. Most of the time there is something. Most of the time it's some fancy init container that starts and injects secrets into environment variables. Or in a more ideal world, something where in my day job we're actually very close to is you just don't use any secrets, right? But that's something that gets very complicated. Again, its whole own talk, probably its whole own conference. But stuff to think about is stuff like workload identity and actually having identity baked into your infrastructure that is running on it. So the CNCF project would be spiffing Inspire, or stuff in AWS calls it pod identity, which is conceptually the same thing, which is the idea that just your workloads have a specific identity they can cryptographically sign, and the endpoint you're authenticating to just can check that by the standard. It's just cryptography. Yeah. So the next big thing, and something I'm very keen of, that's why it's the only slide that has a beautiful image. It's actually directly stolen from another talk I did at KubeCon last year, 2 years ago in Salt Lake City, is the beloved soft supply chain security, which is not really a Kubernetes topic, but it is nowadays, I think, the second most common entry vector into enterprise IT systems, besides human failure or something like that. And also, a lot of the times it's the vector you cannot detect at all. So that's what's quite important to talk about. So what is the idea? Something we do very commonly in cloud native land is just run some images, right? It's the whole promise of Docker. Docker run next. Wow, we've got a web server. And a lot of people do the same thing in their clusters, right? If you're running a reverse proxy or if you're running your ingress controller, most of the time it's going to be some kind of upstream image. Which again is pretty well, right? You wouldn't run any thing you don't know in your own home. We do that in our software all the time. Yeah. And additionally, you can go even way further. It's very common to just pull any libraries from everywhere you know. npm install is the most famous one now, but also like Maven, Central, PyPy, stuff like that. And so how can we make sure on an infrastructure level to be at least a bit secure from these kinds of attacks? I'm just pulling some random image in the internet, how do I make sure that it's actually mine, right? My dev teams publish software to their some container registry, and I pull it. How do I make sure that I actually pull the software that my development teams built, and not some hacker, replaced them in the meantime in the registry or something like that. And so first step everyone should think about is in general like software bill of materials. The idea is just know what your software is made of. It's a huge whole own world. In the container landscape, it's very common to use CDE scanners to at least have a basic gist of what's running in your containers. The very standard one is Triggy. So you can just, if you're in control of the CI pipelines that your developers use, ideally you could just add a step that a Triggy scan happens after every container image, and there's a standardized JSON format that drops out of it, which is basically just a list of all libraries used. And many artifact stores also support this by default. Artifactory is the most well-known one, Harbor, the open source one, has an integration with Triggy, stuff like that. And so then you actually at least know what's part of it. So if somebody has, if the next log4j comes up, you can go to the place where you store all your SBOMs and look for the library that is affected and see who's affected. But to get more to the Kubernetes side of things, you should also do is sign your images and ideally attest stuff that's happening on it. So what's the idea? imagine your development teams build their Docker images. That's the point in time where you're quite sure this is the source code your development team's actually built. That's the source code they want to ship. And that's the point in time where you should use the checksum of the Docker image of the OCI image and sign that, right? So Docker is basically just layers of SHA checksums, and you should sign that here on the secure side. And you can enforce that in your Kubernetes clusters as well. We'll get to that. But for the signing side of things, the important tools are cosign and SigStore stack, which is very, very easy to use if you're running applications in clusters that have internet access. You can build this within a day, easily. You just have to call cosign if you're running a GitHub Actions or GitLab Actions. It does the whole fancy shebang of getting certificates, using them for signing, doing the trust in the back automatically. How does it do that? It's quite complicated. The idea of SigStore is that you can authenticate via OIDC, again, and get a very short-lived certificate out of that. It's only 10 minutes, and generate a private key from that and use that for signing and then throw it away. And there's a public ledger. It's in the internet. It's run by a company founded by Google, Red Hat, and a couple of others. And your cluster, if you deploy them, fancy tools can automatically sync with that and ensure that every tool, every image that is signed with SigStore and cosign is valid. That is actually the one that's signed. So that solves the solution of know that your software is your software. If you want to build stuff like that yourself, I don't know if you guys work at large enterprises, most of them have their own PKI already or have more advanced needs, like you don't want to trust some public certificate authority, you don't want to trust that a random startup founded by Google runs its infrastructure well. You can use the whole notation notebook project stack to build your own. That's what we're currently doing. Yeah, Redify I'm going to get back to. And how do you actually use this to get back to Kubernetes? How do we actually evaluate and enforce the stuff we just learned? So for the admission stuff, so in Kubernetes there's a general concept called admission. Every time you do a request to the API server that is able to mutate stuff, it will go through. Yeah. Yeah. It will go through. I'm almost done. It will go through to a step called admission. So basically, what's happening here? You can have custom logic to tell Kubernetes, please check these rules and reject if they're not compliant. So you can use this for everything we just talked about in the whole section about container security. So the first step was don't allow stuff like root containers, don't allow stuff like that. You can write policies for that. The very nice thing within Kubernetes itself are validating admission policies to do that. It's native, you can just deploy them right in a custom programming language. And there's two very common open source tools to do that, Kubernetes and Gatekeeper. They work through webhooks. So you can configure in Kubernetes a webhook. Kubernetes should call anytime a resource is mutated, and that webhook can decide. You could also program that yourself. It's just an HTTP webhook. And Kibana and Gatekeeper also have integrations with the whole signing stuff I just talked about. But considering the time, I mean, that's my favorite topic. We can discuss it in all deepness, but I will come back to it. And AppArmor can actually be used. It's a pretty cool tool. You can install in your cluster. It's also eBPF based, and you can deploy policies to do actually workload hardening. It's also quite an advanced topic, but you can basically write rules to control the behavior of the applications when they're already running. So admission is always you're creating or editing a resource, and the API server can decide if that editing is allowed. AppArmor is behind that. It's when something is already running and watching that. So AppArmor is actually running on your OS. Yeah. So to get it done, and of course, last point and the most boring, but the favorite for corporate offices, auditing and monitoring. It's actually quite important to know what's happening in your cluster. For example, if somebody, we just talked about supply chain vulnerabilities, if someone managed to breach your container registry and manages to run a container that is not yours on your cluster, it's impossible to detect that with default measures because it's running exactly like your application should run, right? So that's the time where auditing is very important. So what you should do is at least turn on Kubernetes audit logs. It's Kubernetes built-in feature. Then Kubernetes just writes down everything that's happening with the username that's authenticated. And if you've done your authentication well, which was the first slide, You will then know who's doing stuff. So maybe the service account is doing weird stuff that it shouldn't. Then you could probably think about that maybe compromised. There's also a lot of runtime security tools. The most well-known one is Falco, which is a huge open source project by Aquasec. It's also hosted in the CNCF. Falco basically does very similar thing that antivirus software does on your computer. It watches mainly kernel logs on your OS and can detect erroneous behavior. It cannot block it, but it can log it. So the most well-known thing, and sometimes that we annoy our developers with is if you start a bash shell within a container, that's usually not necessary at all. That's something you can detect and log. You can also block that with AppArmor, but then you're going to annoy your developers who are trying to debug. But if you have it logged and realize that later on you've had a breach, you can go there. And also, something that you can do if you're running a large scale or in large organizations, there are several very proprietary tools, and it seems Wiz, Palo Alto, Prisma Cloud, CrowdStrike, etc. Those are all. Wiz is the fancy new kid on the block. They actually do agentless security, but they also have endpoint detection. Palo Alto and CrowdStrike, all the older players, they're basically selling antivirus software which works on your cloud as well. They have great tools, especially they're very fast. So the new fancy way of exploiting something within Linux comes out, they will have the rules to detect that deployed within hours most of the time, which is pretty cool, but it's also not feasible to do that on a platform engineering level. Like that's something your company has to buy centrally and has to roll everywhere. And that's also something that only makes sense if you actually have something like a blue team and an incident response team. So I don't think it's another one of those very advanced tools. It costs a lot of money, and it only makes sense if you have people watching 24/7 and getting woken up if there's an incident. So for large organizations, this makes a lot of sense. Wiz has agentless scanning tools, which have nothing to do with Kubernetes, which also make a lot of sense and are way cheaper in small organizations. But yeah. So to wrap everything up, the most important thing is Kubernetes is not secure at all. We're getting there. You can go. I really recommend going to KubeCons and watching the SIG security maintainer track, and especially the SIG auth. So there's a special interest group within the Kubernetes project who's only concerned with auth. And I really recommend watching those maintainer track talks because it's pretty cool, because Kubernetes just wasn't designed with security in mind, and bringing it in there is quite hard. But SIG auth is responsible for, there's very cool attacks against the API server. Very detailed ways they're thinking about. I love talking about this stuff, so maybe if you want to guys connect after that. And Kubernetes security is very, very complex when diving into details. Maybe you noticed that because I started talking very fast on the last few slides, but it's actually not really hard to follow best practices. And if you got those things I listed there, as basically the first few slides, all set, you're already quite good to go. And especially before diving into the complex details, before installing Falco and having fancy AppArmor rules, you should make sure that the first few steps are done well, and are done well by everyone who's using your clusters. And last but not least, there is a great ecosystem of tools to help. Those are very complex, but most of them are open source and pretty active. It's a great, huge community around that. And so, yeah, there are several tools you can use. You'll never run out of work. Like if your job is to secure Kubernetes clusters, you can start easily and you can advance and advance and advance. And in several years, there'll still be more stuff you can do with open source tooling and getting to work. So, yeah, that's my quick talk. Thank you for listening. I'm here for any questions or chit chat or networking.